Hello there and welcome to this Pandas challenge, day 13. My name is Valentine and I'll be your instructor. In this challenge, we're going to be going through a set of Pandas concepts that are important for data analysis as well as manipulation. So let's get started. The first thing that you need to do is to visit the description link of this video, and once you get to that link, it should take you to, it's written practice resource link. It should take you to a page that looks what you're seeing, like what you're seeing on the screen. Then you can click on the sample practice resource link. That should eventually get you this particular page. So once you're here, the first thing that you need to do is to go to File, then save a copy, to have a copy of this notebook on Google Drive. And if you're an Afterwork member, you'll get access to the practice notebook, which contains more challenges. Okay, so on my side, I will just use the practice notebook and open it in playground mode. I won't be using the sample notebook instead. All right, so once we are here, the first thing that we need to do is to import the Pandas library for data manipulation. So you can just run it anyway. It will take just a few seconds to get started. So once that is done, we will go through now the first concept, creating a new column with the assign method. And it's important to note that when we are working with data, we might want to create new columns. And so generally there are many ways, but this is one of the ways that we can be able to create new data, especially when it comes to preparing data for machine learning. So sometimes you might want to perform what are called feature engineering techniques, and one of those techniques would involve creating new features. So in our case, we might have this data set. So if I load it, you should see it, and in this data set we have these columns, but the data contained here is just in reference to orders made by customers, and we might want to create a new column called discounted price, which would be based off total price, and taking into account that there's a 10% discount for each and every total price that we have. So so how do we do this? So assuming that we might want to create a new column, we can use the assign method, then specify the name of the new column name, that's discounted price. If it's two words, you can use delimiter characters, or just leave it as it is, and use an underscore to separate the words. But now we have discounted price, and we would equate it to df total price, that's the total price column, times 0.9. That will give us now the values for the discounted price, and then we apply that operation to our original data frame, and we display the output. All right, so on the far side, we have discounted price, which is the new column. Right, pause the video and then work on the challenge. We can also decide to detect anomalies in our data set. So there might be data sets or data records that would have values which are dissimilar or are not quite similar to the existing records. So to be able to detect anomalies, we can use the IQR method, or we can use other methods such as using z-scores, or we could also decide to use some other advanced techniques. But for our case, we're going to just quickly learn how to use the IQR method. So first of all, we'll load the data set, and we would want to determine or to identify outliers or anomalies as those records that have operational costs larger or smaller than the rest of the dataset values or records. So for instance, what we might want to do is to calculate the interquartile range, as well as the first quartile, as well as the third quartile. And this would give us values that we can use to determine what are called lower and upper bounds when it comes to using the IQR method. So our lower bound would be Q1, which would calculate from this operation, minus 1.5 times IQR, which would calculate from this operation. We do the same case with the upper bound. And then here, what we are doing is we are performing Boolean indexing, and we are getting the records in the data frame where the operational cost is less than the lower bound, and or the upper bound, or the operational cost is greater than the upper bound value, and we display the anomalies afterwards. So these are the two data sets which have some anomalies. Pause the video and then work on the challenge. In some cases, we might want to create a pie chart in order to visualize some insights about possibly some categorical data. So for instance, if we have this data set and we wanted to represent the distribution of any of the categorical data, it could be department, we can decide first of all to count the frequency of the values of that categorical variable by using the value counts function, which would essentially give us the counts of the values. So for department column, the engineering values, they're 25, quality control 25, IT 25. And we can decide then later onwards to create a pie chart, just visualize that distribution of the categorical data. And we apply the plot function to that summary that we got of the count. And we specify the kind parameters value to be pi, and we set the value of percentage, the percentage values to be 1 decimal point, and we also specify a starting angle, which will just rotate the pie chart to whatever angle, or to whatever angle that we want. If we specify maybe to 190, to rotate again. Okay, pause the video and then work on the challenge. Aside from creating a pie chart, we can also create a line chart to be able to visualize trends and patterns in data. So for instance, if we have this data set here and we wanted to visualize how temperature changes with time, we could also do the same case with humidity, pressure, wind speed, cover, cloud cover, etc. For just temperature, we would first of all need to ensure that the data that we are working with, or the column, has it has a datetime format or data type. So we use the toDateTime function to do that. Then we use the plot function we actually apply it to the entire data frame, but we decide to specify on the x-axis we want date. We want temperature to be on the y-axis. We specify the kind of plot that we want. We change this to whatever type of plot, as well as we specify the title. This is only if we want to quickly create some visualization that would give us some insights that would be useful quickly. Alright, pause the video and then work on the challenge. In some cases, we might want to filter date records, and this just ensures that we're able to get records within a certain date. So for instance, if we wanted to retrieve maybe records that have maybe a particular expiry date between some dates, two dates, then we can decide first of all to convert those date time columns that we have. So here we have expiry date, we have manufacturing date. For this case, we're just going to convert them so that they have a date time format. But then, because our filtering revolves around just the expiry date, we can then just quickly specify the starting date as well as the end date, and then have a Boolean expression, or Boolean, we use the Boolean indexing approach where we specify the two conditions, and we treat now the dates as we would treat just the values that we would have when it comes to just comparing or checking for whether columns have values that we want or not. And that's it. We display the filtered data. Just note that here manufactured date, we haven't used it anywhere, but for just ease of learning, we just included it there. Pause the video and then work on the challenge. We can also create a cross-tab table to summarize the relationship between two or more categorical variables. So for example, if we have this particular data set, we can decide to create a summary table that contains on left hand side category, then on the right hand side it would contain multiple columns based off status. So you could have category, then status, which would be shipped and delivered, those two categories, but there could be more, and you'd have their respective values. So it could be that in this case we just want to get that relationship. So in our case we might have, like, you know, on the left hand side category, here we have electronics 15 were delivered, 11 have been shipped, 12 were delivered, 13 were shipped, etc. Right, pause the video and then work on the challenge. All right, moving on. We could select data using the query method as we've seen in the past. It's an easier method to use. So assuming that we have this data set and we just wanted to retrieve records that have category equal to electronics, we just use the query method and we specify our condition, which we want to check for whether the category column is equals to electronics, and we retrieve those records, store them in electronics data, and that's it. Pause the video and then work on the challenge. In some cases we might want to go over or iterate over through just records. Assuming we have this data set, we might just want to iterate through each and every record that we have here. It just allows us to be able to manipulate each record to how we want. So for example, in our case over here, we might have some sort of data set that we've called DF, but we would want to iterate over it and access values that are in those particular records. So for example, we would use a for loop and we specify the two variables that would contain the current elements, the index of the current element, as well as the rest of the values for that current element, which would be a row. And this is how we're able to specify that we would want to iterate through the data frame. So we df.iterRows. So yeah, for each and every iteration, for the first record, we would iterate and we can get the row ID. That's 1001, 1002, using row, that's the current value, as well as now specifying the column name. We store those values in a different variable, and we can do whatever that we want. You'll note that here we haven't used index, but in many cases you might find some use cases for it. Yeah, so, and we even end up calculating new values, which we could end up even deciding to create a new column for it. But here we're just displaying at the very end the order ID, as well as the product name, as well as the total cost, which would be as a result of what we would have here. Right, pause the video and then work on the challenge. We can also handle missing values in data. So assuming that we had this data set that you see here, and right from just this preview, you can see that there are few missing values. But if you wanted to check how many missing values are there for each column, we can specify, we can write this code df.isNull, then we apply the sum function, and that should give us the count of missing values for each column. So we have 0 missing values for the first 3 columns, but we have 2 missing values for the quantity column and 1 missing value for discount column. If we wanted to easily deal with the rows in a way that may not necessarily impact the overall performance, or it may not necessarily impact our analysis, and if we have deduced that's the case, then we can just decide to drop all the missing values if we realize only 2 or 3 missing or 3 records have missing values and that may not significantly impact our analysis, then we can drop those records with missing values, and we just do that by saying drop NA, by using drop NA function, and we apply it to the original data frame, and we can store the result in a new data frame called data cleaned, and you can check the missing values in that data cleaned data frame, and you can see we don't have any missing values. Right, pause the video and then work on the challenge. We can also select columns in a data frame. So assuming that we have this data set, again, this is just a repetitive session, but again, it's concept that we've worked on in the past. Just for ease of quickly reinforcing what you've learned, this is how we can select specific columns. We just say df square brackets, then inside it we specify the list that contains the column names that we want, and yeah, we store that in selected columns and display that. All right, pause the video and then work on the challenge. Okay, so that's it with regards to this challenge. We hope it was a bit easier, as we do expect that you've covered others in the past, and we do hope that you'll keep on continuing with this journey. If you did like this video, found something valuable, be sure to give this video a thumbs up, and if you'd want to be informed when we post such future challenges, be sure to subscribe, and all the best in your learning journey. Bye bye.